Hi students, this is the Dr. Maya Dunne. I'm coming to show you the copy of Introduction to Measurement Lab. This lab will learn about the mass and the volume measurements, and also we try to familiar with the units using dimensional analysis. So part 1 is direct. It asks you to find the reading always whenever let me have the answers. So whenever you finding the volume, it always you see you should go for the meniscus. Meniscus means at end of the curvature. If I draw it here, like like that. So you don't read it here. No, that's wrong. You read it in end of the meniscus. So that's the reading place would be. So when you pick the reading, because it's the same thing enlarged over here, and then you select your answer. And then I'm going down. Now that we covered how to measure the volume, let's take a look at the mass. Reading tail 0, pouring the liquid. The reading on the scale was 42 before the added. So it says reading is 42 before it added. Now it's 166.6. So what is the mass of water? You have to so first they put the instrument called the graduated cylinder, and they put the graduated cylinder, and then the mass of the graduated cylinder is 42.2, and then you need to subtract the mass of the graduated cylinder in order to get the mass of water. Now you know mass of the water and the volume of the water. And I go down, and then this is the next one. When you finish first part, you move to the part 2. In part 2, we learn about graphing and unit conversions. I go down. So then you have to watch the video. Watch the video. So let me run video a little bit and get one measurement. So here it is the okay, and then let's play the video. Then I need to start over. Please allow me some time. Okay, I'm going to play this video. Explain now. So first you get the reading. Okay, you know. Okay, empty cylinder. Okay, before that, let me go there. Okay. Okay, the empty cylinder weight is 96.4. At that time, you don't have any. So they by looking at these readings, you fill this graph. So the graph they ask, okay, measure the mass 96.4, and then liquid mass is 0. You don't add any liquid. If you go to the second reading, because at that time you don't have any liquid, and now you know the mass is 96.4. Okay, the weight 124.2. The volume you measured from here, the volume is 22, and the mass, total mass, is 124. And how do you get the 27? You subtract the mass of the measuring cylinder from the mass of the total volume, because this 124.1 is the mass of the measuring cylinder and also the water. So then in order to get the liquid mass, you subtract the mass of the cylinder, which come to the 27.79, and then the volume is 22. How do I get the 22? Because this in this screen it shows the volume. This screen it shows the mass. So like that you have to get, I think, 5 or 6 readings. So please get all the readings, and then you can add a graph. Okay, so the graph, when you have all these answers, you should get a graph something like this. Okay, so this is the graph you get, and then so you should expect, if you have all the readings right, you should expect this kind of a graph. And then I go to the next question, which is, now that you found the mass and volume, we need to figure out density. What is the density? Density is, let me go to the next page. Always, density, I'm sorry, I'm writing the other way today. Density is mass divided by volume. But we have many masses and volume. You may wonder why we plot a graph with many readings to get more accurate results. So from the graph, we need to get the density. So the graph equation is y equals mx plus c. Y-axis is mass, and then this is intercept mass. Okay, intercept. X-axis is volume, mass and volume. Density is mass divided by volume. This is m, so it goes, okay, mass divided by volume, m. In here it's the density, volume. So you can get the density by mass divided by volume, which is the intercept of the graph. Okay, which is the intercept, which is m. And then you go down, and then using the density value you found in the last question, what is the identity of the liquid? You have to find what is the most closest number you get from the graph, and then write the answer. And then I'm going to go down. Density is a powerful tool to find the number of moles in a liquid sample. We can use the density to calculate the mass of a liquid from the volume. Remember that unit in a both numerator and denominator. So in order to cancel out, you always need to use this principle. Given unit, so you need to get an answer in the desired unit. Okay, in order to get the answer in the desired unit, I think I did it in the your notes too. Desired units equal given unit, desired unit. I'm sorry, the way I'm writing is bad. Sorry. Okay. Desired unit equals given unit desired unit divided by given unit. So here, given unit cancel, you end up with the desired unit. The same principle here. If you have the sample of milliliter of the liquid from the video above, which one would be equal to the grams? So in order to get the grams, there should be the milliliters, right? And then the grams on the top. So you have to find what would be the answer if you have sample of X milliliters. So you know, but you have to find the answer. So what would be the mass of 42 milliliter of the glycerine? So you have to find the density from here. You know, density of the glycerine, which is 1.26 grams per milliliter. So you know the density equals mass divided by volume. Density getting from the table, which is 1.26 grams per milliliters. You have to find the mass, right? You have to find the mass. So it is going to be m and then 42 milliliters. Milliliters cancel, and then mass would be 42 multiplied by 1.26. Okay, like that you have to find it, and then that's the end. And it's that's I hope the video is helpful, and try to answer the questions and submit the lab. Thank you.